Geological Survey in Flagstaff, Arizona. And Robert Haberlin is the co-investigator for Mars Color Imager on the NASA Mars Reconnaissance Orbiter. He's with NASA Ames Research Center in Alpha Field, California.
Okay, good morning everyone. I'm happy to announce that Mars is alive and active in many ways, both the surface and the atmosphere, and we think including surface flows of water today, even in equatorial regions. So I'm going to start with a video just to review active Mars surface features at least, and then we'll each talk about new results. But initially this is a very quick tour of Mars and its activity. So I think we start at the polar regions, and this shows a polar pit in the south polar residual cap of carbon dioxide, dry ice. These are growing over time, not shrinking, repeats. And Bob Haverly will talk more about that. At the North Pole, we have these giant scarps with avalanches that occur every spring as soon as the sun first hits these steep slopes. There are hundreds of these active dust CO2 avalanches. I think that's what they're composed of, and blocks of ice also fall down. And these are active as we observe. This is a little sequence of 3 color images, about a second between each image, so this is just about the actual speed, if you can see it actually moving there. We also, the polar regions each winter are covered in CO2 frost that condenses out of the atmosphere. And when the springtime comes, it defrosts in very interesting ways, forming patterns. This just flips between 2 images showing some of the spots. Here's a sequence of some dunes defrosting. They're frost covered. Cracks form on the surface in the CO2. These lead to eruptions of dark material from pressure of CO2 gas that builds up and erupts. We get dark sand flows on the steep slopes. The wind blows the dark material. Eventually it's completely defrosted. So this happens every year, both poles. The Martian spiders are one very distinctive feature that forms, especially in the south polar region, associated with these active processes. The dunes are active. Here you can see a little sequence where you can watch the ripples move along, and even the whole dune is moving by about a meter per year, per Mars year. There's a close-up look at that, and you can see some of the avalanches on the steep slope as well. There are dust devils, including some really monstrous tall ones. Here's a video that JPL put together the other year, based on a high-res image, but animating the motion of this, both the rotational motion and its motion along the surface. These happen in particular times and places on Mars. Here's an example of 2 active processes. First, a new impact at the top, and that impact triggered this very large dust avalanche. So this is a dusty slope. And here's another example. The darkest streaks are the most recent avalanches, and then over decades these fade as dust is deposited from the atmosphere. The gullies on Mars are active. This shows one example in Gossa Crater. They're especially active on sand dunes, but this is a non-sand dune location. The blue deposit you see there at the bottom, that's the fan. That's new material that was deposited. And here's a little quick blink movie showing new deposits on the fan. If you look closely, you can see lobes, new lobes of material, maybe a couple meters thick, that were deposited. We're surprised to find that these dunes are active in the winter and the spring when there is CO2 frost in the ground. That seems to be driving the activity, current activity. Here's another example showing dark material flowing down the channel in the springtime. This is all frosted, so and we haven't seen the topography change here, but this is another type of activity that occurs commonly. We have found hundreds of new impacts that have formed over the past decade or so. Some of these expose ice, and Colin Dundas will talk more about these ice exposed by impacts, clean ice. Now I'm going to talk about recurring slope lineae, a terrible name, but these are potentially water flows. They're dark streaks that form now in the dust-free areas of Mars They form and grow incrementally down the slope. Steep slopes, rocky slopes, the warmest times of year, and then they fade when they're inactive and recur in multiple years. Here's another JPL animation, as if you're in a helicopter flying through this crater and watching these change over periods of weeks, so the helicopter is not on a tight schedule, I guess. So that we found these initially in the southern middle latitudes, and that made a certain amount of sense because we know there is shallow ground ice in middle latitudes, as the new impacts hope to illustrate, but also on steep equator-facing slopes. So these are places where they get quite warm. So it's like the intersection of this residual ground ice and warm areas. That seemed to make sense. More recently, we have found that these slope streaks are active in equatorial regions of Mars, which is a bit more puzzling. And I'll go here to the PowerPoint presentation here. And okay, so recurring slope lineae in equatorial regions of Mars. We've now seen many of these, particularly in Valles Marineris, which is this deep canyon whose length is that of the United States from coast to coast. Some of these are rather long, more than 1 kilometer in length. The picture here shows an arrow that marks some of these. They are quite similar to the mid-latitude RSL and how they behave. Steep rocky slopes, they grow incrementally, then fade. But what's unusual here in the Valles Marineris region, you don't get strong seasons, it's at the equator, but instead they're active on north-facing slopes when the sun is to the north, and then it switches to activity on the south-facing slope when the sun moves to the south. And so there's seasonality associated with what slope aspect you're on. Here is a global map showing first the global altimetry from the MOLA experiment, Mars Global Surveyor. Red and white are high, blue is low. And at the bottom is an albedo map from the TESS instrument and plots of the confirmed RSL sites. These are sites where we've seen the full yearly sequence. And we see lots of these in the southern mid-latitudes. A bunch of them in Valles Marineris and close to Valles Marineris in smaller canyons. There's one in the northern mid-latitudes that we found so far, although it's a bit unusual. They occur at many altitudes except the very highest altitudes. We haven't found them above 2 kilometers. And they strongly prefer the darkest, lowest albedo portions of the planet, which are the least dusty areas. Here's yet another animated GIF, and there are more of these on the HiRISE website. This is a spot in Juvente Chasm, and this shows the close relationship between the RSL and pristine gullies. These are equatorial gullies, and you can see that there's a good match in size between the RSL and the gullies, and so this could be what is forming these gullies today. So who cares? So what? Well, this has implications for future exploration of Mars, in a positive sense, because this gives us a focus of where to look for extant life. There's lots of other challenges besides water, but nevertheless, these are at least relatively promising sites to explore further. This also could affect future exploration in terms of something called special regions, where extra planetary protection is needed, extra safeguarding, sterilization before we send a lander or rover to those spots, because we don't want to contaminate it with earthly microbes. Previously, the equatorial region was considered non-special. This may require some reconsideration of that. So I will turn it over here to Colin to talk about icy impacts.
All right, thanks, Alfred. Alfred was just talking